Assalamu alaikum and good morning everyone. In this video, we'll be discussing linear programming problems and simplex method of operation research asked in university examination from 2017 to 2022. The first question was asked in October 2018. As we can see, the question is maximize z 3x1 plus 8x2 subject to constraint x1 plus 3x2 less than equal to 10, x1 plus 2x2 less than equal to 4, x1 greater than 0, x2 greater than 0. So here we're going to start with the solution. The step 1 will be convert into standard form. Convert into standard form. Since the constraints are given in terms of inequalities, we have to convert in terms of equation. So x1 plus 3x2 plus s1 equal to 10. Then x1 plus 2x2 plus s2 equal to 4. x1 comma x2 comma s1 comma s2 greater than equal to 0. Whereas optimized function max z is equal to 3x1 plus 8x2 plus 0s1 plus 0s2. So here we have converted the given example into standard form. That is my step 1. Coming to the step 2 will be finding initial basic feasible solution. In short, it can be written as IBFS. So put the main variables, that is x1 and x2, equal to 0. So from equation 1, this can be your equation 1 and here it your equation 2. So from equation 1 we can get s1 equal to 10 and s2 equal to 4. Now step 3, that is the, so you have to remember the table for constructing the example using the simplex method. Here we are going to have the basis variable, left we are going to have cj, top we are going to have the cj, and here we are going to have the variables x1, x2, s1, s2, b, and the last one will be your replacement ratio. Basis variable will be your s1 and s2. Then we're going to find zj, and last will be your delta. Delta will be your cj minus zj. So this structure of the table you have to remember while solving the simplex method. So cj is nothing but the coefficient of the objective function. Here is my objective function. So coefficient will be 3, here will be 8, 0 and 0. And s1 coefficient will be same 0, 0. Now first equation we are having x1 plus 3x2 plus s1 equal to 10. We have to collect all the coefficient of the variables. So x1 coefficient is 1, x2 is 3, s1 is 1. Since s2 is not present, it will be 0 and b will be your 10. h2 will be your 1, then 2, 0, 1 and 4. Since we have collected all the coefficients from the equation, now zj. How to find the zj? So zj can be found by multiplying the cj column with each exercise. Cj will be multiplied with x1, cj will be multiplied with x2, cj will be multiplied with s1, similarly with s2 and similarly with the b. So here we're going to have 0 into 1 plus 0 into 1. So the answer will be your 0. So each element from cj column we have to multiply with the elements of x1, x2, s1, x2 and b. So again here we're going to have the entry will be 0, 0, 0 and 0. Since the delta is cj minus zj, so 3 minus 0 will be 3, 8 minus 0 will be 8, here will be 0, 0. When we say the solution is optimum, When all delta is less than equal to 0, we say solution is optimum, which means we have reached the final stage. But here we can see all delta is not less than equal to 0. We are having positive 3, positive 8. So here we're going to have the filtering part. So for filtering part, so most positive value, or you can say highest positive value, will be the indication for the entering variable. So 8 is the highest positive value. So 8 correspond to the variable x2, which means the entering variable will be your x2. Entering variable is x2. As we can see in basis variable, we are having only two places, that is s1 and s2, and one extra variable x2 enters the table, which means any one variable have to exit. Since in basis variable we are having only two positions available for the variable, it is already occupied by s1 and s2. When we say the one new variable enter the table, which means any of the existing variable have to exit the table, because for the two place three variable cannot be occupied. So this yellow section represent the key column. So key column is 3 and 2. So replacement ratio is given by the formula B upon key column. B upon key column. So B is 10. So 10 divided by 3, it will be approximately 3.33, and 4 divided by 2, it will be simply 2. So for entering highest positive value corresponding to the variable will enter the table, and for leaving lowest positive value will leave the table. So lowest positive value is 2, that is corresponding to h2. So leaving variable is h2. So h2 will enter and h2 will leave. Got it everyone? Entering variable is x2 and the leaving variable is h2. Since here we are only discussing the paper solution, we are not going in detail how we are getting the actual calculation and what will be the calculation process for solving each and every example. So for that you have to watch my the previous video of simplex method. So that can be seen in the top of the table, that will be the card will be displayed over there. So next table we are going to make. So in next table again the table section will be same, that is basis variable. Left hand side will be your cj, again here will be your cj. Main variable will be, now see, the entering variable is x2 and leaving variable is h2. S1 will remain as it is. At position of h2 we are going to have x2. The variables are x1, x2, s1, h2, b, and last one will be your replacement ratio. So coefficient of s1 is 0 and coefficient of x2 is 8. So here we are going to have 3, 8, 0, 0. Always remember, whenever we are having the entering variable is x2, leaving variable is h2, so that position will be represented as the key value. So key value is your 2. How are you going to decide the key value? Entering will be your variable, and for exiting the variable you have to take the turn. So that corner position will be decided as your key value. Entering and then taking turn to get exit from the table, that turning position will be your key value. So key value is your 2. Optimum solution, we have to make the key value as 1. We have to make key value as 1. Here we can see first row will be denoted by r1, second row is denoted by r2. First row is denoted by r1, second row is denoted by r2. So what we have to do, we have to make 2 as 1 in the next table and 3 we have to make a 0. The formula will be made using one element from the row, but it will be applied on the entire row. So how we're going to make a 2 as a 1, since it is a 2 and we're going to divide it by 2. So from where this 2 we have taken, that is from R2, and this is my extra 2 that we have taken in the denominator. So it will be your R2 divided by 2. After doing this operation, we're going to get the key value as a 1. So here we can see all the element entry for x1 in second row was 1. So it will be your 1 by 2. Previous entry was 2. So put in this formula. It will be 2 upon 2. Answer is 1. Here it will be 0 upon 2, 0. It will be your 1 upon 2 and 4 upon 2 is 2. Got it everyone? 4 upon 2 is 2. And for making 3 equal to 0, we have to make an formula, that is your R1 minus 3 upon 2 R2. R1 minus 3 upon 2 R2. So the entry will be minus 1 by 2. Here it will be 0. It will be 1. It will be H2 will be your minus 3 by 2 and B will be your 4. So all these entries we have to take from the previous table for calculating the next table entries. Next we are having the ZJ. Then we're going to have the delta. Delta will be your CJ minus ZJ. How are we going to find the ZJ entry? Each table entry of CJ have to multiply with the each column of x1, x2, s1, s2 and b. So 0 into minus half 0, 8 into 1 by 2, that will be your 4. 8 into 1 will be your 8. 8 into 0 will be your 0. 8 into half will be your 4 and 8 to the answer will be your 16. So delta will be your 3 minus 4 minus 1, 8 minus 8 0, 0, 0 minus 4 is minus 4. As we can see, all the delta are less than equal to 0, which means solution is optimal. So we have reached the final position where the delta is the combination of 0 and the negative values. So where we're going to have the final answer. So here we're going to have the final answer. Final answer is my 16. In this particular section of the basis variable, we can see x2 equal to 2 and x1 is not present, which means it will be your 0. So max z is equal to 16, that we have already found over here. When there is no entering variable in the table of the simplex method, so there will be no replacement ratio. Replacement ratio is found unless there will be a entering variable into the table. If there is no entering variable, so there is no need of making a variable exit from the table. So replacement ratio will not found when we are having the delta as a combination of 0 and the negative values. So here we can see the maximum z equal to 16. For this two table calculation, we are getting 7.5 marks. It is easy. These are basic calculation that we have already done in the school times. Got it everyone? It is easy. Put in the comment whether you get the solution or not. 18. A manufacturer manufactures two product A and B. These products are produced on two machines 7.5. Oh sorry, 7.5 is the a manufacturer manufacture two product A and B. These products are produced on two machines M1 and M2. The processing time in the hours required per unit of these products and resources capacity are as under. So here the table is given. Profit per unit is rupees 8 for the product A. Profit per unit is rupees 5 for the product B. Formulate the linear programming problem and solve the graphical example. So here we are going to have the solution. So profit per unit of A. So here we can see profit is 8 rupees for product A. Profit is 5 rupees for product B. So A let product A be x1 and product B be x2. So for product A we can see 5x1. Here we are going to have इसको हमने x1 ले लिया है and इसको हमने x2 ले लिया. So equation we are going to have 5x1 plus 3x2. It will be less than equal to 30. For solving the maximum, always remember there the sign of the inequality. It will be less than equal to 30. Second, we're going to have 2x1 plus 5x2 less than equal to 20, and we can see x1 comma x2 greater than equal to 0. And the optimized function max z is nothing but 8, that is the profit per unit of product A, 8x1 plus 5x2. So this we have done the formulation of the linear programming problem. Now the second part we have to solve by the graphical method. So how to make a graph? So first we're going to make a table for 5x1 plus 3x2 equal to 30. So here we're going to have the table for x1 and x2. Always remember we have to assume one of the value is 0. If x1 is 0, x2 will be your 10. Put in this equation. If x1 is 0, so this entire value will be your 0. 3x2 will be equal to 30. So x2 will be your 30 upon 3, that is 10. If x2 is 0, then x1 will be your 6. If x2 is 0, this entire part will be your 0. 30 will be equal to 5x1. So x1 will be 30 upon 5, that is 6. Similarly, we are going to make the table for the second equation equal to 20. So here we are going to have x1 and x2. So again, assuming the value x1 equal to 0, x2 will be your 4. If x2 is 0, x1 will be your 10. These all values we have to put on the graph paper, and we have to make a graph. So after plotting the value, you can see the given graph. So first equation, that is 5x1 plus 3x2 equal to 30. Here we are going to have the line on the graph paper. Second, we are going to have 2x1 plus 5x2 equal to 20. Now we can see in the first equation the inequality was less than equal to. Again here the inequality was less than equal to. We have already used equality sign. Only remains is to check where we have to apply, or where we're going to have the points using this less than equality. So here we are having the 4 region. We can see first region. If we're going to put the point in the first region, we can see for the first line it is satisfying the equation, but for the second line that it is not satisfying. As we can know, it is given the less than equal to, which means for the first line all the points will lie below the line, and for the second line all the points will lie below the line. So this first region does not satisfy the second line. As we can see, all the points for the second line have to lie below the line, but we are having the points above the line, which means it's not satisfying the equation. So we cannot take the region 1. Region 2 again we cannot take because it does not satisfy any of the line. For region 3 we can see it satisfy the first line, it satisfy the second line, but not satisfy the first line. For first line the arrow is below the line and we are getting the points above the line. So only region we left with, that is a fourth region, and that is a highlighted by the given line. So make sure always that you have to cover the boundary for solving the equation. So total we are having the vertex as vertex O. So total we are going to have the 4 points, that is vertex O. Its coordinate is 0, 0. Then vertex A, the coordinates is 0, 4. And vertex B, the coordinates are 2.1, 0, 5 and 4.737. You can easily approximate this point by 2.1 and 4.7. So point B can also be written as approximately 2.1 and 4.7, and point C will be your 6, 0. So these are all the points that is satisfy the feasible region of the given example. So here we are going to have quadrilateral OABC is a feasible region. So their boundaries are OABC. So their coordinates are already given. Now all these coordinate we have to place in the objective function, that is max z. So max z is your 8x1 plus 5x2. So z at O. So it will be your 8 into 0 plus 5 into 0. So answer will be your 0. Z at A. It will be your 8 into 0 5 into 4. So the answer will be 20. Z at B, 8 into 2.1 plus 5 into 4.7. So the answer will be around 40. It will be around 40. Z at C, it will be 8 into 6 plus 5 into 0. So answer will be your 48. So we can see the highest profit we are getting is 48 at point C, whose coordinate is 6 comma 0. Got it, everyone? Among all the values of the optimized function, the highest value will be considered as the profit. So profit is 48. At which point we got? At point C, whose coordinate is 6 comma 0. Again, we have to solve using the graphical method. A company produces two products A and B, where X1 and X2 are the quantities manufactured of product A and product B respectively. The following objective function along with the constraint is given below. Max Z is 8x1 plus 16x2, where constraint are given x1 plus x2 less than equal to 200, x2 less than equal to 125, x1 plus x2 less than equal to 300. So using these three constraints, we have to optimize the profit using graphical method. So let's begin again the same calculation as we have done in the previous example. First will be your x1 plus x2 less than equal to 200. So second, x2 less than equal to 125, and the third, x1 plus 2x2 less than equal to 300. So first table we're going to make for x1 plus x2 equal to 200. Again same calculation as we have done in the previous example. Similar form of making a table. X1 equal to 0, x2 will be 200, x2 will be 0, x1 will be your 200. X2 equal to 125. Simply x2 equal to 125 will be there. X3, next x1 plus 2x2 equal to 300. So again make a similar form of table, x1 and x2. If x1 is 0, x2 will be your 150. If x2 is 0, x1 will be your 300. Now all these value we have to put on the graph paper. On x-axis we have taken the variable as x1, and on y-axis we have taken the variable as x2. Since the table was made for the x-axis and y-axis, so here the equation had frame in terms of x1 and x2. So the conversion will be your x1 and x2 axis. Instead of x and y axis, we have converted x1 and x2 axis. So after making the equation plot on the graph, we're going to get such kind of graph. As we can see, we are having the boundary point as A, B, C, and D. So the coordinates, that is quadrilateral O, A, B, C, D, is feasible region. So the coordinates of O is 0 comma 0. Coordinates of A is 0 comma 125. This coordinate we can easily get seen from the graph. Next we are having point B. So point B is your 50 comma 125, and point C is your 100 comma 100, and point D is your 200 comma 0. So these are all the coordinates. Now all these value we have to put in objective function, that is max z. So max z is 8x1 plus 16x2. First we're going to check at z at O. It will be your 8 into 0 plus 16 into 0. The coordinates of O is 0 comma 0. So at place of x1 we're going to put 0, and x2 place we're going to put 0. So here the answer will be your 0. Next we are having z at A. It will be your 8 into 0 plus 16 into 125. So here we're going to get 2000. Next one, z at B. It will be your 8 into 50. It will be 16 into 125. So the answer will be your 2400. Z at C, it will be your 800, 8 into 100 plus 16 into 100. Again, the answer will be your 2400. And the finally, Z at D will be your 8 into 200 plus 16 into 0. So the answer will be your 1600. Now, from all the values, we can see the maximum value we are getting at the 2 position. The maximum value we are getting at 2 position. So the profit is 2400 at point B and point C. So the next example is solving the example using the graphical method. Again, the similar process as we have done in the previous example. The question was asked in the November 2022. So let's begin. 2x plus 3y equal to 48. Making the table will be in the form of x and y. If x is 0, y will be your 16, and y is 0, x will be your 24. Next we are having x less than equal to 15, which is similar writing of x equal to 15 and y equal to 10. All the constants we have done. Here we can see all the point will lie below the table of 2x plus 3y less than equal to 148. Y less than equal to 15, which means all the point will lie below the line. X less than equal to 10, which means all the point will lie behind of x equal to 15. So here we're going to have x equal to 15 and this is your y equal to 10. This is your printing mistake. We have misplaced the equation. It will be your y less than equal to 10. Y less than equal to 10. So after plotting the graph, the boundaries will be your 0, D, E, F and C. This is my quadrilateral feasible region. If feasible region exists, which means solution will exist. If feasible region not exist, the solution will not exist. So first we have to find the feasible region. That is your common region. That is highlighted by the black pen. So one by one we'll all put all the value in the optimized function. So here we can see max z is your 40x plus 80y. So first coordinate of O is 0 comma 0. Here is my first coordinate 0 comma 0. So after putting the value we're going to get the 0. Second, the coordinate of D is 0 comma 10. So 40 into 0 will be 0, 80 into 10 will be your 800. Now the coordinate of E. So coordinate of E is 9 comma 10. So 40 into 9 360, 10 into 800, 10 into 80 will be your 800. So final answer is 1160. Next coordinate of F is 15 comma 6. So 15 into 4, 40 will be your 600. 6 into 80 will be 480. The answer will be 1080. And point finally C will be your 15 comma 0. So finally we are getting 600. So among all the values, maximum value is your maximum value we can see is 1160. Maximum value is 1160. So the profit is 1160 at point, or you can say the coordinate of point E is 9 comma 10. So at point E 9 comma 10 we are getting the maximum value, that is 1160, that will be considered as the profit. Got it everyone? Next example is maximum z 100x plus 80y subject to constraint 6x plus 4y 7200, 2x plus 4y less than equal to 4000, x greater than equal to 0, y greater than equal to 0. The question was asked for the 7 marks in November 2022. Similar form as we have done in the previous example, just you have to remember the steps. So first step 1, convert into standard form. Convert into standard form. So the conversion will be 6x plus 4y plus s1 equal to 7200. 2x plus 4y plus h2 equal to 4000. S1, h2, x and y all are greater than equal to 0. Max z will be your 100x plus 80y plus 0 into s1 plus 0 into s2. That complete my step 1. Step 2, finding IBFS. Step 2, finding IBFS by putting x comma y, or we can say x and y equal to 0. So after putting x and y equal to 0, we get s1 equal to 7200 and h2 equal to 4000. So now getting the actual calculation of the simplex method, that is my step 3. Just you have to remember, here is my equation 1 and here is my equation 2. Just remember the table format. So the table format will be your basis variable. The top will be your Cj, left will be your Cj. The variables are S1 and S2. The variable will be your X, Y, S1, S2, B, and the final column will be your replacement ratio. So first we're going to collect all the coefficient of the objective function of X, 100, Y 80, S1 0, S2 0. Similarly, we're going to do for the left hand side, that is Cj. Now we're going to collect all the coefficient from the equation 1, that will be 6, 4, 1, 0, and B is my 7200. So the values after equal to, that will be considered as the value of B. H2 will be your 2, 4, 0, 1, and will be your 4000. Now we're going to find the Zj. Zj will be your all the entries of Cj will be multiplied with the each column. So answer will be a 0, 0, 0, 0, and 0. And next we're going to find the delta. So delta will be your simply Cj minus Zj. So it will be your 100, 80, 0, 0. We can see the delta is greater than equal to 0. The solution is not optimal, which means we have to make a filter part to get the solution as optimal. So among delta, the highest positive value corresponding to the variable will enter the table and the lowest positive value will exit the table. So here we're going to see 6 and 2, that is my key column. 6 and 2 are my key column, and the replacement ratio will be given by the formula B upon key column. So here is my 7200 divided by 6. So the answer will be your 1200. 4000 divided by 2, the answer will be your 2000. So among the 1200 and 2000, the minimum positive value is your 1200, which means entering variable entering variable is x and leaving variable is s1. So the common part, that is a junction of entering and leaving variable, will be considered as your key value. So key value is my 6. Key value is 6. So what we have to do, so we have to make key value as a 1, and all other entries corresponding to key value have to make 0. So here we can see, here is my R1 and here is my R2. So first row, that will be denoted by R1, second row denoted by R2. Now what we have to do, we have to make the key value as 1. So how we're going to make key value as 1? Here we're going to have 6. If simply we're going to divide it by 6 itself, we're going to get the 1. So this 6 we have taken from the R1, and this 6 we have externally multiplied. 1 by 6 we have externally multiplied. So again we're going to make a table, since the given table is not optimum. So we're going to make a new table, basis variable. Here we're going to have Cj. Again we're going to have Cj. Here we're going to have the variable x, y, s1, s2 and b. X, y, s1, s2 and b. And the last will be your replacement ratio. So the entering variable was x and the leaving variable was s1. Next we're going to have s2. So the coefficient of x is 100 and coefficient of x2 is 0. Here we're going to have 100, 80, 0 and 0. Now since 6 come in the first row r1, so we're going to do the operation as r1 upon 6 to make the key value as 1. So 6 upon 6 1, 4 upon 6 is 2 by 3, it will be your 1 by 6, here will be your 0 and the finally will be your 1200. So all this entry for making the entries from the next table, all the values we have to take from the previous table. So here we have taken r1 upon 6. This r1 we have taken from the previous table. 6 upon 6 1, 4 upon 6 2 by 3, 1 by 6, it will be your 0 upon 6, 7200 divided by 6, it will be your 1200. Now for making the second table, that is your making the value 2 equal to 0, we're going to put 2, then we're going to put 6. Now simply what I have to do, I have to make 2 minus 6 after editing with the term equal to 0. So how are we going to do? Just divide by 3. If you're going to divide by 3, if 6 is divided by 3, we're going to get 3 ones are 3, 2s are 6 and 2 and 2, it will going to get 0. So what we have done, these 2 we have taken from the R2 and 6 we have taken from the R1 and divided by 3. So using this operation, we're going to make the 2 equal to 0. So the answer will be your 0. Here it will be your 8 by 3. Here it will be your minus 1 by 3. Then we're going to have the 1 and the last will be your 1600. Then we're going to find the zj and we're going to find the delta. Here the answer will be your 100. Next will be your 200 divided by 3. Just multiply cj. Just multiply cj with each column of xy, s1 and s2. So here we're going to get 100 by 6, that will be your 50 divided by 3. Next will be your 0 and the answer for the zj will be your 1,20,000. It will be your 1,20,000. Now we're going to find the delta. The answer will be your 0. Then it will be your 40 upon 3. It will be your minus 50 upon 3. Here will be 0. Now again we can see delta is not optimal because delta is combination of greater than equal to 0. One of the positive value again exists in the delta, which means solution is not optimal. Solution is not optimal. Again we have to do the similar part to make the solution as optimal. So highest positive value corresponding to the variable will enter the table, that is 40 upon 3, and the leaving variable will be your lowest positive value will leave the table. So highest positive value is 40 upon 3, that is corresponding to the variable y will enter the table. Replacement ratio is given by the formula b upon key column. So 1200 divided by 2 divided by 3. So here the answer will be your 1800. Next will be your 1600 divided by 8 divided by 3. So here the answer will be your 600. So the lowest positive value corresponding to the variable h2 is 600 will leave the table. So the entering variable is your y and leaving variable is h2 and the key value we can see is 8 by 3. Key value is 8 by 3. Now what we have to do in the next table, we have to make 8 up by 3 as 1 and 2 by 3 we have to make 0. 8 by 3 as 1, we have to make 2 by 3 as 0. Again we're going to make a table, that is your basis variable. Here we're going to have cj, above it will be your cj, x, y, s1, H2, B, and the last column will be your replacement ratio. So the entering variable is your Y and leaving variable is your H2. So in place of H2, we're going to place Y. So that it will be the coefficient will be X will be 100, coefficient of Y is 80. So here we're going to have 100, 80, 0, 0. Now 8 by 3, just multiply by 3 by 8, this part will become 1. So for making the number 1, simply multiply by its inverse, opposite part, inverse part. By multiplying by the inverse part, we're going to get as a 1. So 8 by 3 come to the second row. So we're going to have 3 by 8 multiplied by R2. 3 by 8 multiplied by R2. So the answer will be your 0. Here it will be your 1. It will be your minus 1 by 8. And H2 will be your 3 by 8. Now we have to make the 2 by 3 as 0. Just we're going to have R1 minus R2 upon 4. Using this operation, we're going to make 2 by 3 as 0. Here we're going to have 1, 0. S1 will be your 1 by 4. H2 will be your minus 1 by 4. And B will be your 800. And here we're going to have 600. Now we're going to find the ZJ. And the final we're going to find the delta. So ZJ will be your 100. Here it will be your 80. Here it will be your 100 upon 4. 100 upon 4 minus 80 upon 8. So after doing the calculation for ZJ, we're going to get the 15 and here we're going to have the 5. And this part will be your 1,28,000. 1,28,000. So delta will be your 0, 0. It will be minus 15 and here will be minus 5. Now we can see all the delta are less than equal to 0, which means solution is optimal. Solution is optimal and value of X is your 800, value of Y is your 600 and max Z we are getting 1,28,000. That is my final answer. Got it everyone? Example number 6. Here we given profit per unit of product A is 5, for B 3 and C 4. The example was asked in November 2022 for 8 marks. Now we're going to see how easy the question, how easy the solution is given for the given question. You can easily getting the 8 marks. So first we're going to make the, first we're going to copy the table. Here we're going to have product, product A, product B and product C. Here we're going to have the raw material P, Q and R. So product A entry is empty, 20, 50. Here we're going to have 20, 30 and the empty, then 30, 20 and 40. And we can see the maximum raw material availability for P. So where is my P? P is in the column form. So you are going to have availability. So availability of P is 80 units, availability of Q is 100 units and for R is 150 units. So given example is the profit, that is maximized part. So we're going to take the value as let unit A, let profit per unit A be X, let profit per unit A be X, unit B be Y and unit C be Z. So let unit A be X, unit B Y and unit Z, unit C be Z. So the first equation we're going to make the column form. So the column form में here we will going to have, since the entry of the product A is empty, which means it is a 0, the entry will be 20Y plus 30Z less than equal to 80, then 20X plus 30Y plus 20Z less than equal to 100, and the last one will be your 50X plus 40z less than equal to 150, and we can see all those entries are positive, which means x comma y comma z is greater than equal to 0. And the maximized z, that is the profit part, it is given 5 for unit A, 3 for unit B, and 4 for unit C. So using just doing the 3 to 4 step, we are getting the 8 marks in the final examination. Is it easy? Next example was asked in November 2019 using graphical method. Solve the linear programming problem. Objective function is 3x1 plus 4x2 subject to constraint 3x1 plus 2x2 less than equal to 18, x1 less than equal to 5, and x2 less than equal to 6. So first equation for 3x1 plus 2x2 equal to 18. Again making the table in the similar format that we have done in the previous example. x1 equal to 0, so x2 will be 9, x2 will be 0, then x1 will be 6. Next we are having x1 equal to 5 and x2 equal to 6. Putting all these values on the graph paper and tables. So first equation 3x1 plus 2x2 less than equal to 18. So here we're going to mark the arrow that all the points will lie below the line. x2 equal to 6, all points will lie below the line. x1 equal to 5, all points lie behind the line. Now we have to find the common region which satisfy all these arrows, all these constraints that is already given, that is a highlighted part. This part, that is my feasible region which satisfy all the arrows, all the constraint of the equation. So the quadrilateral O, A, B, C and D, which means we are finding the boundary points. These are the boundary points. O, A, B, C, D is called as your is feasible region. So the coordinate of O is 0 comma 0, coordinate of A is 0 comma 6, coordinate of B is 2 comma 6, coordinate of C is 5 comma 1.5, and coordinate of D is 5 comma 0. Now all this coordinate we have to put in objective function, that is max z is equal to 3x1 plus 4x2. So z at O will be your 3 into 0 plus 4 into 0. So the answer will be 0. Z at A will be 3 into 0 plus 4 into 6. That will be your 24. Z at B will be 3 into 2 plus 4 into 6. So 24 plus 6, that will be your 30. Z at C will be 3 into 5, 15 plus 4 into 1.5, that is 6. So 15 plus 6 will be your 21, and the last will be Z at D will be 3 into 5 and 4 into 0. The answer will be 15. So among all the optimized function max Z values, the maximum value is 30, which means the profit is 30 at point B, whose coordinates are 2 comma 6, whose coordinates are 2 comma 6. Got it everyone? Example, as we can see, it was asked in November 2019. So using simplex method to solve the following linear programming problem, maximize z, that is 4x1 plus 7x2, x1 plus 3x2 less than equal to 18, 4x1 plus 2x2 less than equal to 8. So this part will be your homework part. Your homework, you have to use the similar idea as we have used in the previous example. So here the x1 will be your 0, x2 will be yours 4, x1 will be 0, x2 will be your 4. So the final answer will be optimized function, that is given as max z 4x1 plus 7x2. The final answer will be your 28. Further, if you're going to have the calculation part. Now solve using the simplex method. Solve by using the simplex method. Maximize z is 15x1 plus 5x2 subject to constraint 4x1 plus 5x2 less than equal to 100, 5x1 plus 2x2 less than equal to 80, x1 greater than equal to 0, x2 greater than equal to 0. So here we're going to have the solution part. Step 1, convert into standard form. Convert into standard form is the similar idea that we have done in the previous example. No need to worry that 4x1 plus 5x2 plus s1 equal to 100, 5x1 plus 2x2 plus h2 equal to 80, where x1 comma x2 comma s1 comma h2 all are greater than equal to 0. Maximize z is your 15x1 plus 5x2 plus 0 into s1 plus 0 into h2. This converted into the standard form. Step 2 is finding the IBFS, that is initial basic feasible solution, after substituting or after putting the value x1 and x2 equal to 0. So we are getting s1 equal to 100 and h2 equal to 80. So here is my equation 1 and here is my equation 2. So we have now the step 3 is a actual calculation part, that is a basis variable. Here we're going to have Cj. Here we're going to have Cj. The main variable is S1 and S2. Then we're going to have Zj, and finally we're going to have the delta. So the variable are x1, x2, s1, s2, b, and we're going to have the replacement ratio. So s1 will be 0, s2 will be 0. The coefficient of objective function is 15, 5, 0, 0. So from the first equation we're going to get 4, 5, 1, 0 and 100, 5, 2, 0, 1, and we're going to have 80. So Zj is simply multiplying each entries of the Cj with the corresponding column of x1, x2, s1, s2 and b. So we're going to get 0, 0, 0, 0 and 0, 0. So delta will be your 15, 5, 0, 0. Now we can see, since all the delta is greater than equal to 0, the solution is not optimal. So among all the positive value, we have to pick the highest positive value. Will going to, among all the delta, we have to pick the highest positive value corresponding to the variable will enter the table. So the entering variable is x1 and the key column will be your x1, 4 and 5. So the replacement ratio will be find using b upon key column. So 100 upon 4 will be your 25, 80 upon 5 will be your 16. So among all the entries of the replacement ratio, the minimum value is 16, that is corresponding to h2, which means h2 will exit the table. So leaving variable is your h2, entering variable is x1, and the junction of s1 and the junction of x1 and h2, that is 5, will be your key variable. So key value is 5. Now what we have to do, we have to make key value that is 5 equal to 1 and corresponding value that is 4 equal to 0. Again we're going to make a table, that is basis. Here we're going to have Cj, s1 will remain as it is, instead of h2 we're going to have x1. So the variables are x1, x2, s1, s2 and the b. In the year we're going to have replacement ratio. So s1 will be 0, x1 will be your 15. So 15, 5, 0, 0. Here we're going to have, here is my r1 and here is my r2. So 5 come under the r2 section. So we have to make 5 equal to 1. So simply divide 5 by 5, it will become a 1. So this 5 we have taken from the R2 and we are dividing by 5 to make the value equal to 1. So in second row, we're going to apply the operation R2 divided by 5. So it will be your 1, it will be your 2 upon 5, it will be 0, it will be 1 by 5, and 80 divided by 5, it will be 16. It will be 16, 80 divided by 5. Now we have to make the 4 equal to 0. We're going to make an operation R1 minus 4 by 5 R2. Using this operation, we're going to make 4 equal to 0. So all these R1 and R2 we have to take from the previous table. So here will become a 0. Here will become a 0. Next we're going to have the 17 upon 5. Next we're going to have 1. Then minus 4 upon 5. And B will be your 36. B will be your 36. Next we're going to make a table of Zj and then will be your delta. So how are we going to find the Zj? We have to multiply each entry of Cj with the corresponding column of x1, x2, s1 and s2. So here we're going to have the 15. Here we're going to have 6. This will be your 0 and here it will be your 3. So 15 into 16, it will be your 240. So we can say 15 minus 15 0. It will be minus 1 0 minus 3. Now we can see all the deltas are less than equal to 0, which means the solution is optimal. So we have reached the final state where x1 equal to 16 and x2 is equal to 0 and max z we are getting 240. So in this way we are solving the simplex method example. Next example we are having again just to do the formulation and we have to solve by the graphical method. देखो मैं आपको जो है फॉर्मुलेट करके दे देता हूँ. सॉल्विंग वाला जो पार्ट है दैट इज अ ग्राफिकल पार्ट दैट यू कैन डू इजीली एज वी हैव ऑलरेडी डन इन द प्रीवियस क्लासेस ऑफ द लीनियर प्रोग्रामिंग प्रॉब्लम्स. तो वहाँ से आप रेफरेंस लेकर के इस एग्जाम्पल को आप सॉल्व कर सकते हो. द फॉर्मुलेशन पार्ट आई विल गोइंग टू डू. So let for f1 be x and for f2 be y. So for f1 and we're going to have for f2. Next we are having f1 and f2 को छोड़ के हमारे पास information क्या है? We are having the information of vitamins. We're going to have the information of minerals. We're going to have the information of calories. So 1 unit of 4F1. Now see the third line. 1 unit of 4F1 have 6 units of vitamin B1, 1 unit of mineral and 3 units of calorie. 1 unit of 4F2 contain 1 units of vitamins, 4 units of minerals and 1 unit of calories. Now at least requirement for the sick person for the vitamins is, here we are going to have the requirement. So at least requirement for vitamins is 18, 12 for the mineral and 10 units for the calories. This 7.5 is the marks highlight. The question was asked for the 7.5, because of that the 7.5 is placed over there. Horizontal way it will be a 6x plus y greater than equal to 18. You are going to have x plus 4y greater than equal to 12, 3x plus y greater than equal to 10, and all these value, what is the costing of the food, that is 4 and 8 respectively. So here we are going to have minimum z 4 for x and 8 for y. So here we are going to have the equation 4x plus 8y for the minimum z and where x comma y is greater than equal to 0. So this is the formulation part of the given example. Now this example you have to solve using the graphical method. The example was asked in the examination, that is November 19. Again for the 8 marks, the given linear programming problem simplex method is the case study example asked in the examination in November 19. Now the table is given. Now the table is given. They have asked us whether the given example is optimal. First we can see the question, check about the solution is optimal or not. If it is not optimal, find the optimal solution. Then the second part, find the optimal product mix, resources are scarce and utilized. In case of alternate solution, justify your answer. What are the shadow prices of the given example? Justification. So each example needs a justification and here the table is given. Since we can see the z is given, delta is not found. So if you're going to find the delta, here we're going to have 30 minus 20 will be 10. Here it will be 0 minus 20. 0 and 0, and we can see since the delta is greater than equal to 0, we are having one positive value, which means solution is not optimal. So what we need to do, we need to make a second table to find the optimal solution. We're going to make a second table to find the optimal solution. So here we're going to have the basis variable. Here we're going to have Cj. Here we're going to have Cj. Variables are x1, x2, s1, s2, s3, s1, s2, s3. Here we're going to have b, and we're going to have replacement ratio. So the table which was given in the example, that we are copying it for our calculation part, we're going to have x2, s2, s3, 40, 0, 0. We're going to have 30, 40, 0, 0, 0. Here we are having 1 by 2. Here it was 11 by 2, was 1, 1, 0, 0. 1 by 2, minus 5 by 2, minus 2, 0, 1, 0, 0, 0, 1, and b is given 100, 100, 100, and zj is given as 20, 40, 20, 0, and 0. And we have found delta is 10, 0, minus 20, 0, and 0. Since there is a one positive value, which means that 10 corresponding to x1 will enter the table, and some variable have to exit the table. How are we going to find the replacement ratio part? That is b upon key column. So here the key column is my 1 by 2, 11 by 2, and 1. So the replacement ratio will be 100 divided by 1 by 2. So here will be your 200. So 100 divided by 11 by 2. So the answer will be in somewhat 18.18. And next one we are having 100 divided by 1. So the answer will be your 100. So we can see the most smallest value, that is your 18.18 corresponding to h2 will exit the table. So here the key value is 11.2. Entering variable is your x1, and leaving variable is your h2. Leaving variable is your h2. Got it, everyone? Now what we have to do, similar calculation. Here is my r1, r2, and r3. What we have to do, we have to make 11 upon 2 as 1, 1 by 2 as 0, and corresponding 1 again. So here we're going to have the basis variable. Here we're going to have cj. Here we're going to have cj. Here we're going to have x2, x1, and s3. 40, 30, 0, x1, x2, s1, s2, s3, b, and the replacement ratio. So 30, 40, 0, 0, 0. So here we're going to have the operation for r1 will be your r2, r1 minus r2 upon 11. Second will be your 2r2 upon 11. And for the third one, it will be your r3 minus 2 upon 11 r2. Using this operation, we're going to make the corresponding values of the key column equal to 0. So here we're going to have 0, 1, 8 upon 11, minus 1 upon 11, 0, 1000 upon 11. X1 will be your 1, 0, minus 5 upon 11, 2 upon 11, 0, and here it will be 200 upon 11. For S3, it will be your 0, 0, minus 17 upon 11, minus 2 upon 11. S3 will be your 1, and B will be your 900 upon 11. ZJ will be your 30, 40, 170 upon 11, 20 upon 11, 0, and B will be your 4182. Delta will be your, here will we have 30, 40, 0, 0, 0. So it will be 0, 0, minus 170 upon 11, minus 20 upon 11. Here we are going to have 0. Since all delta is less than equal to 0, solution is optimal. Solution is optimal. Got it everyone? तो ये हो गया हमारा फर्स्ट पार्ट. ये हो गया हमारा फर्स्ट पार्ट. चेकिंग फॉर द ऑप्टिमैलिटी, सॉल्यूशन वाज नॉट ऑप्टिमल, देन वी हैव फाइंड द ऑप्टिमल सॉल्यूशन. नाउ द थर्ड पार्ट इज गिवन. ये हो गया हमारा ए का कैलकुलेशन कंप्लीट. पहले ऑप्टिमल नहीं था, हमने ऑप्टिमल चेक किया, फिर उसके बाद हमने उसका सॉल्यूशन भी फाइंड कर लिया. नाउ फ्रॉम द बी पार्ट वी आर हैविंग द थर्ड क्वेश्चन. द थर्ड क्वेश्चन इज फाइंड द ऑप्टिमल प्रोडक्ट मिक्स. मीन्स मतलब हमको x1 x2 की वैल्यू फाइंड करना है. सो x1 इज 200 अपॉन 11, x2 is 1000 upon 11. So the max z is 4182. यहाँ से हम देख सकते हैं we have already found the max z is 4182. So this complete the third part. This complete the third part. Next we are having question 4 का क्या पूछा है आपको? Find which of the resources are abundant and scarce. Abundant and scarce के लिए आपको चेक करना है. देखो यहाँ पे values of S1, values of H2 and values of S3 in the basis section. In basis section we are having S3 which is a value of 900 upon 11, which means there is some part of the total value of S3 is available, and in the basis section we see there is no H2, which means H2 is equal to 0, no S1 which is equal to 0. When there is no value present in the basis variable, so corresponding value will get as the 0, which means this resources will be your scarce, this will be your scarce, and here it will my abundant. देखो कैसे पता चलेगा ये हमारा abundant है. abundant का मतलब बचा हुआ, scarce मतलब खत्म हो गया. तो बेसिस सेक्शन में आप देखो यहाँ पे कौन सा वेरिएबल प्रेजेंट है. तो S3 प्रेजेंट है, मतलब S3 के पास 900 अपॉन 11 कुछ क्वांटिटी मिल रही है. S3 के पास जो क्वांटिटी है 900 अपॉन 11 वो कुछ मिल रहा है, मतलब S3 के पास अभी भी कुछ क्वांटिटी बची हुई है. दैट विल बी योर abundant resources. इस पर्टिकुलर सेक्शन में, बेसिस वाले सेक्शन में S3 प्रेजेंट है, S1 और S2 है ही नहीं, मतलब वो जीरो हो गया. तो जो जीरो हो गया मतलब वो पूरी तरह से यूटिलाइज हो चुका है, मतलब वो खत्म हो गया हमारा. तो दैट विल बी योर स्कार्स रिसोर्सेज. तो S1 विल बी योर स्कार्स, H2 विल बी योर कार्स. आपको कैसे पता चलेगा कि हमारा स्कार्स है ना? आपको बी को चेक करना है. अगर बी की पोजीशन पे अगर वहाँ पे आपको जीरो मिल जाता है तो हो जाएगा हमारा स्कार्स. अगर कुछ वैल्यू मिलती है पॉजिटिव, दैट इट विल बी योर abundant resources. Got it everyone? Now we have to check for the alternate solution exist or not. For alternate solution what we have to do? In the basis section, the variable which is not present, for that we have to check the delta. If delta we are getting a 0 which is not present in the basis section, then the solution will be your alternate solution, or we can say more than one solution exists. So we have to check for the non basis variable. So non basis variable means जो variable यहाँ पे present नहीं है. So non basis variables are S1 and H2. Non basis variables are S1 and H2. So for that we are going to check delta S1. What is delta S1? We are getting minus 170 upon 11, and for delta H2 we are getting minus 20 upon 11, which is not equal to 0, which means there is no alternate solution exists. No alternate solution exists, or you can say there is no more than one solution. So here we can say solution is unique. नॉन बेसिस वेरिएबल के लिए अगर कोई भी आपको जो है वेरिएबल के लिए, नॉन बेसिस वेरिएबल के लिए अगर आपको डेल्टा 0 मिल जाता, विच मीन देयर विल बी मोर देन वन सॉल्यूशन, वी कैन से ऑल्टरनेट सॉल्यूशन एग्जिस्ट. बट यहाँ पर हमको क्या हो रहा है कि नॉन बेसिस वेरिएबल के लिए डेल्टा वी आर नॉट गेटिंग इक्वल टू 0, विच मीन सॉल्यूशन इज यूनिक. एंड द लास्ट वन, सिक्स्थ वन, from the table we have to find the shadow prices. So shadow prices means we have to find just the values of zj corresponding variables. So zj for s1, we are getting 170 upon 11. Zj for S1 we are getting simply 170 upon 11, that is a value. Zj for S2 we are getting minus 20 upon 11, and Zj for S3 we are getting equal to 0. So in this way we have solved the examples of linear programming problem and simplex method from previous year 2017 to 2022. Hope so.